Hello everyone, Locke here. This is a tutorial on creating the wing strut assembly. Try to do this as efficiently as I can. There are three pieces here. I'm not going to worry about the attachment hardware like L brackets. I'm just going to use three pieces of wood, and I'm going to create these objects in OnShape and try to assemble them, and we'll see how it goes. Each of these pieces of wood is 12 by 3.5 inches and 3/4 inches deep, according to that drawing. If we look closely, all three of these are the same, and the only difference is that two of the pieces are going to have different holes. So this one it's the same size, but different hole, and then down here, yeah, that's 12. Just trust me, it's 12 by 3.5. All right, so going to go into OnShape. I'm going to create a new document. We're going to call this the wing strut assembly. The first part studio, I'm just going to have this. I'm going to rename this the base. And I'm going to create a sketch. Go ahead and use the front plane. So front plane will be my sketch plane. 2-point corner rectangle. I'll start at the origin. It really doesn't matter, I don't believe. I'm going to go 12 inches wide and 3.5 inches tall. So 12 wide, 3.5 inches tall. I am done with that sketch. Anytime if I'm going too fast, you can pause it and rewind it. Going to extrude this. I'm going to go 0.75 inches, 3/4 inch. All right, and that's the base. If I want to assign material here and create wood, usually I can scroll down and find wood, be it pine or poplar or something like that. Just looking for wood. I must have skipped past pine here. I don't see it. So let's just look for wood. All right, there's ash. I don't see it. So if it's close enough, it's close enough. We'll just use that. And if I want to change the appearance, I could make it look a little closer to wood. Brownish. All right. Stained wood. All right. So the shortcut to this is, instead of going through that whole process again, I can just right-click on this and duplicate, and rename this. I'm just going to call this the upright. It's the fuselage, but it's the upright part. And on this part, I believe they call it part 2. That hole that is right here is in the middle, so it's 1 3/4 from one side. It is 9 inches from one end, probably from the bottom end, and then it is 0.266 through. So if I look at this from the front and I sketch on this plane, I should be able to, I can draw a circle or a point, should be able to just create that right in the center. And I can go ahead and either type in 0.266 for this. If I did a hole feature, I could create a clearance hole for, I believe, a 1/4 inch part, but since they've given me the diameter there, I'll just type that in. And then I'm just going to dimension it, D for dimension, but I can come up to the dimensioning tool and make sure that's 9 inches. So all these are in US customary. And I'm fairly certain that if I just dimension that real quick, this should be 1.75. I don't need to dimension it, it'll over dimension it because it's actually constrained. It's in this, it's collinear to that center point right there. But you can either dimension it or you can geometrically constrain. And then I'm going to create an extrusion where I'm going to remove material there. I can do blind or I can do through all. So there is the hole for that upright. And that satisfies that dimension. Now, the last one is I'm going to go back to the base and I'm going to create 4 holes that are going to be 6 inches from this datum, this reference edge, and 9 inches. And they'll be 2.5 and 1 inch. So they are 1 inch from each end and 3 inches apart because 9 minus 6 is 3. So I'm going to go back to the base. I'm going to duplicate it. I'm going to call this is really the wing. So the upright is the fuselage, but the wing is where and that's going to be duplicating the base right here. But now I'm going to create a sketch. And I'm going to put 4 circles. And I believe they're all the same diameter, 0.266. And I probably could use a copy and paste feature here, or a pattern feature. I'm just going to create each of these quickly. I could line it up and see how that works, because these are going to be even. But I'm going to dimension each of these. 9 inches for those 2. 6 inches for that one. So it looks like I have to dimension that one as well. Did not line them up. And then 1 inch. 1 inch. There are ways to do this geometrically as well, where I could, but I'm only doing this once. I'm not being super fancy here. But those are the 4. And so they're 1 inch away from each edge here, but they're 6 and 9 inches. And I know this one is also 9 inches because it was geometrically constrained. So going to extrude and remove each of these, face of those, and then I'm going to do through all. And I believe we have our 3rd piece. Now, to assemble them, I would bring in the base first. I'll click that in. And I'm going to be okay with that for a second. So one of the things that you can do if you want this to actually lay down flat, because according to this picture, the base is actually laying down flat, and depending on which orientation you want to see, which is the front view, I'm going to just position it so it's laid down flat where it's flat on the XY axis, or I'm looking at it from the top view. In this particular section, the front view actually would be from the side. So I'm going to go ahead and do both of those things. If you don't really follow me. So here's the front, but if I double click on this, I can swing this down 90 degrees and hit enter, or I should be able to, yep, left click. So that's front, but I'm going to turn this, double click this again, look in the top view, I'm going to swing this here 90 degrees. And so here's my front view. Now that means that I'm actually going to be assembling the upright to the back right here. So I don't know if you see this, but technically the front view is looking at this part from, really, I mean, most people call it the side, and then the side view is actually looking at it perhaps from some would be the front. But if you look at the multi-view here, you can actually see this is traditionally the front view in mechanical drawings, and this would be the side view. And so that's what I'm doing now, is I made this the front, this edge, and I'm going to put the upright right down next to it, so you can kind of see where it's butting up against it. And so I'm going to do that right here. I'm going to insert, well, first I'm going to do another thing real quick. I'll right click on here and fix this so that this is fixed in space. Don't really care too much about the origin point. I could, but I'm just going to get rid of that for a second. And I'm going to insert the upright, and I'm going to assemble these two pieces, and I'm going to use a couple of different mates that we could use. I could use a fasten, try a fasten here, and I'm going to fasten this. So you have to use these mate connectors, and mate connectors show up in midpoints and at corners. And I'm going to see if I can't fasten this right to that mate connector right there at that edge. Now it's completely upside down, so I'm going to reorient it, and that is using the reorient the second axis. If it's, I could have flipped it, but the flipping actually changes this axis. So I'm going to do that again for you. So I'm going to use a fasten mate, and that basically a fasten mate freezes the object in all directions, like eliminates that. But I have to go find the right mate connector, and so I'm using that edge, and I have to kind of hold my teeth right. Select that one, and then I'm going to come over here, and I'm going to orient that a little bit so I can kind of there. So there are three different positions here: the center and the lower part. And if I don't get it right the first time, I can always, there it goes. And again, it puts it upside down, so I'm going to go to reorient that axis. I'm going to just rotate it around there, and now it's in the center, and I'm going to hit OK. And so that's a fasten mate, and I'm going to do the same thing with the top. I'm going to put a fasten mate on the top part, in that center portion back here, to the top part of that piece of wood there. So let's insert, probably have to close that for a second. So that's one fasten mate. I'm going to have a second fasten mate here in a second. So I'm going to put the wing in here. Need to accept that. Fasten mate. And so it's not on this end. It looks like it's this end right here. Sometimes you have to zoom in on it. You want that to be mated right back here. And it went into the wood. I can see where it's intersecting. So I'm going to select the flip primary axis, and it's going to go right where I want it to. Now there's probably a better way to do that, but it's really nice to have the flexibility of flipping those axes and seeing how that works. Now this is the front, so when I look at this drawing, here's my front, Here is the right side. There's the right side. When I scroll down, if I select this and go to the top, there's the top view, and that's the top view. You can see what we have in common there. Now, that is a fully fastened assembly. And here's one thing that I'll share with you. When you go to create struts, these holes, you can line them up in the revolute mate or the slider mate, probably the revolute mate. If I'm using the revolute mate, if I have something else that has a hole in it, a cylinder, I can use that revolute mate to lock it in, because the revolute mate has, you mouse over these things, it allows rotation about the z-axis, but it is able to lock things in. But you could use a fasten mate as well, because if I use a fasten mate, I could select the center of that point and then put another object to it and fasten it in all directions. But when we do use fasteners and assemblies, there's a lot of times we use either revolute and from time to time a slider or planer or cylindrical mates. You'll have to explore more about assemblies in order to understand those things.